Okay, so again, we're kind of picking up where we left off in the previous video. We're going to kind of expand on it just a little bit by looking at these particle motion problems a little bit differently. But in order to get us back into our thought process, if we want to know where a particle can neither be speeding up or slowing down but still have a positive velocity, again, a positive velocity just means it's moving in either to the right or possibly in an upward direction. But if I want to know how a particle can not be speeding up or slowing down but still moving in that direction, all that would mean is there's no force pulling it in that direction. In other words, if the acceleration is 0, you can still be moving in a particular direction, you're just not speeding up or slowing down. And so that's an important idea to understand, that acceleration is a force, but it doesn't govern what direction you're moving in. It just causes you to speed up or slow down when you look at what's going on with velocity. And so what I want to look at now is what happens if instead of a function, we have a graph specifically of the velocity. So basically what we're going to be doing is we're going to be talking about how to read a velocity graph over the next couple of minutes. So if I look at this graph, notice this is a velocity graph. It says velocity on it. What we have to remember in general is any time a velocity is positive, then we're moving in a positive direction, or upwards or downward, or upwards or to the right. If our velocity is negative, then we are moving in a downward direction. Or if we're talking moving left and right, then we're talking about moving to the left. And if my velocity is 0, then we're not moving in either direction. So this first question, at what time is the particle stopped? Again, this is a velocity graph, not a position graph. So when I look at this graph, I notice at time equals 30, I am neither moving forwards nor backwards, because at that exact moment the particle stops. Even for a split second, it has stopped. Okay? A lot of people, what they want to say is, well, it stopped right here, and that would be true if we were looking at a position graph, but because this is a velocity graph, at that time, we have a positive velocity, which means it's moving in a forward direction. Now, the next question says, on what time interval is the acceleration positive? Well, the acceleration is the derivative of velocity. So if I want to know where the acceleration is positive, I simply look at the graph, and anywhere that the graph is increasing, that means I would have a positive derivative. So here and here on both of those intervals, I would have a positive acceleration because the slope of the velocity is positive. Okay? So anytime you're looking for an acceleration, we look at the slope of the velocity. So in this case, I would say from 0 to 10, and we would also say from like 40 to 55. On both of those intervals, our acceleration would be positive. If I want to see where my acceleration's negative, then I would look at the graph and I would say, okay, anywhere that the graph is decreasing, I would have a negative derivative. So in this case, from 15 all the way to 40, my acceleration is negative because my velocity has a negative slope, which is what we're looking for, because that would make the derivative be negative as well. So hopefully those answers kind of make sense. Let's take a look at one more. Okay, we're still looking at more questions about the same graph. Excuse me. So now I want to know, when is the acceleration 0? Well, that would be anywhere that my velocity has a slope of 0. So in this case, that would be from time equals 10 to time equals 15. So from 10 to 15, my acceleration is 0. Now, here's the last part where we kind of have to tie everything that we've talked about in this particle motion together. On what intervals is the particle speeding up? Well, when I look at this problem, if I want to know where the particle is speeding up, ultimately what I'm going to do, there's one of two ways to look at it. Anytime a velocity graph is moving away from the x-axis as we move from left to right on our graph, we can say that our particle is speeding up. So from time equals 0 right here to time equals 10, notice as I move from left to right, my graph of my velocity is moving away from the x-axis. Another way to look at that, we just barely talked about it, on that interval, the acceleration is positive, and my velocity graph is above the x-axis, so it's also positive. So in this case, I could say from 0 to 10 is one place where this particle is speeding up. Now, you'll notice from time equals 30 to time equals 40 that my velocity graph is all moving away from the x-axis. And if you think about it, the acceleration there is negative, the velocity is negative. So if both the velocity and the acceleration are negative, that means they're working together, kind of like we talked about previously. So I could also say from 30 to 40, my particle is speeding up as well. It's just in the other direction. If I wanted to know where on the intervals in which the particle is slowing down, that's any time the function is moving towards the x-axis. So in this case, I would say that's from 15 to 30, and that's also from 40 to 55. And for similar reasons, on both of those intervals, the acceleration and the velocity do not match up. They don't have the same signs on those particular intervals, so we can't say that it's speeding up, it's slowing down, because they're not matching up. They're working against each other rather than with each other. So hopefully that kind of made sense, kind of tying particle motion all together, especially when we're talking about reading graphs. If you have any questions about this, please come on in, and I'm more than willing to answer any questions that you might have. Thanks a lot.